here we have another functional group is called carboxylic acids. Look at this table. We have different acids starting from methanoic, ethanoic till butanoic acid. All of these acids contain a common thing or a common group which is called carboxyl group. This one is called carboxyl group. So the presence of carboxyl group in a molecule makes it a carboxylic acid. So look at the carboxyl group in this representation, and we have another representations for carboxyl group, COOH or CO2H. Let's learn how to name carboxylic acid. The first step is find the longest carbon chain that contains the carboxyl group. First, let's take the first example over here and start numbering the longest chain. I'm gonna give the carbon of the carboxyl group number 1. So it will be like that: 1, 2, 3, 4. Locate the substituent. Here I have only the bromine, or the bromine is on carbon number 3. So the name of the hydrocarbon chain will end with OIC acid, like that. So it will be 3 bromo butanoic acid. So I dropped E from butane and I replace it with OIC acid, this part at the end, this suffix. So the name of this carboxylic acid is a 3-bromobutanoic acid. Let's name the second one, this example. Let's choose first the longest chain. The longest chain is starting from the carbon of the carboxyl group, 1, 2, 3, 4, 5. So on carbon number 2 there is isopropyl. So the name of this carboxylic acid is 2-isopropyl pentanoic acid. Here we have the ester functional group. The ester functional group is a key structural feature. Here we have the ester functional group. This is the structure of ester. The ester functional group is a key structural feature in fats, oils, and other lipids. It is also found in fruits and flowers. Many esters are fragrant and represent some of the nature's most pleasant odors. You can see here the structure of it and the process that gives a carboxylic ester. When a carboxylic acid reacts with alcohol, this forms an ester linkage between the carboxylic acid part and the alcohol part. So in ester we have 2 parts, the acid part and the alcohol part. To name this molecule, we have to take care or to بس عيدها الآن مثل الخلق كرمال الله عيدها مثل الخلق. Here we have the ester functional group. Is a key structural feature in fats, oils, and other lipids. The ester functional group is also found in fruits and flowers. Also, they are fragrant and represent some of the nature most pleasant odors. This is the structure of ester. You can see here there is an ester linkage between carbon and oxygen. Let's take a look on esterification. Esterification is the process of forming an ester linkage between carboxylic acid and alcohol. So this is the reaction here that lead to carboxylic ester or an ester. So we can say that ester contains two parts, acid part that came from the carboxylic acid and alcohol part that came from alcohol. So remember that the alcohol part is always connected to the oxygen here. So let's learn how to name esters. The first, here I have some exercises or some examples about esters. Let's review together the rules. First, you have to name the alkyl portion that's connected to the alcohol part first. So look at here. Here is the alcohol part, and here is the acid part. First, name the substituent or the alkyl group that's in the alcohol part. So here I have methyl. So this is methyl, it's in the alcohol part. Then name the acid part. The acid part is named as a carboxylic acid, but you should eliminate IC from the suffix and put ATE. So it will be like that. Let's name first this part as a carboxylic acid. 1, 2, 3. So instead of writing 2-methyl propanoic acid, I will write 2-methyl propanoate. So the final name will be like that. So I have to place first the substituent that's in the alcohol part, so it will be methyl. Then 2 again methyl propanoate. Let's name this molecule. Okay, so where's the alcohol part here? The alcohol part here is on the left side. On the left side we have this substituent ethyl. The carboxylic acid part is hexanoic acid, but for sure I will not write hexanoic acid. I will write ethyl. The substituent methyl here on carbon number 4, so it will be ethyl 4 methyl hexanoate instead of hexanoic acid, because it contains, the chain contains 6 carbon atoms. Hexanoate. Aldehydes and ketones are the next functional groups that have carbonyl group. Carbonyl group is over here. Is a carbon to oxygen double bond. It's in aldehydes and in ketones as well. Carbonyl group is critical in biological compounds. It's found in carbohydrates, fats, proteins, nucleic acids, hormones, and vitamins. In a ketone, as you can see here, in ketone, 2 carbonyl groups are attached to the carbonyl carbon atom. Why? In an aldehyde, at least one of the attached group must be a hydrogen atom, and the other attached group can be hydrogen or other carbon group. The abbreviated form or the shorthand form of an aldehyde is CHO, and for ketone is CO. So let's see how to name aldehydes. First of all, select the longest carbon chain containing the carbonyl carbon. So look over here. This molecule is called the butanol because it contains 4 carbon atoms. We start numbering this chain from the carbonyl carbon, 3, 4. So because it contains 4 carbon atoms, it's called butanol. Instead of E, the E ending of the parent alkane, instead of butane, okay, we dropped E and we put Al, so it becomes butanol. Here in the second molecule, give the carbon or the carbonyl carbon number 1. 1, 2, 3, 4. The substituent here is ethyl, and ethyl is on carbon number 2. So it will be 2 ethyl, 2 ethyl butanol, because it has 4 carbon atoms. The last one is 2-methyl pentanol. 2-methyl pentanol. Okay, here start numbering from this carbon: 1, 2, 3, 4, 5, and this is the substituent methyl group. It's on carbon number 2, and the chain is called pentenyl instead of pentane. See how to name ketones. First, select the longest carbon chain containing the carbonyl carbon, like aldehydes. But here you have to number the chain starting with the end closest to the ketone group. So let's plus, you have to drop E from the parent alkane and replace it with the suffix ONE. Let's say how I will do this. Let's take this molecule. So number the chain starting with the end closest to the ketone group. So this, I have this end and that end. So I will start from the right side because this end is closer to the carbonyl group or the ketone group. So this carbon will be carbon number 1, 2, 3, 4, and 5. The name of this ketone molecule is 2-pentanone. So I dropped E from the pentane and I replace it with O and E to indicate that this molecule is a ketone molecule. And carbon number 2 represents the position of the functional group. Let's name this molecule. So here you have to start numbering from any side you want. From here, 1, 2, 3, 4, 5. But on carbon number 2 and carbon number 3, there are 2 methyl groups. So I will write it like that: 2,4-dimethyl, 3, the position of the functional group of ketone, pentanone, because it has, the chain has 5 carbon atoms. Alcohols are organic chemical compounds that include the hydroxy functional group. You can see OH group in these molecules, alcohol molecules. Alcohol molecules can vary in size up to very long molecules, most of which consist of chain of carbon atoms attached to the OH group. So to name the first molecule over here, this one is called ethanol. Propanol. This one is 2-methyl-propanol. Rules for naming the alcohols is: first, find the longest chain containing the hydroxy group OH. Second, give the carbon holding the OH the lowest possible number. So in third example, I gave this carbon number 1. This is 2 and this is 3. So the methyl group is on carbon number 2, so I put 2-methyl. Remove the final E from the parent alkane. So instead of putting propane, I put propanol. So I removed E, remove the final E from the parent alkane and add OL. For the first molecule, let's find the longest continuous chain of carbon atoms. So it will be, because we have OH here, hydroxy group, I will start from the carbon that hold the OH, 2, 3, 4, 5, 6, 7, 8. So it will be octanol because it has OH group and it contains 8 carbon atoms. On carbon number 5, they're an ethyl group, so it will be 5-ethyl, 2, 3 dimethyl. You have to specify the position of OH group. It's on carbon number 1, so 1 octanol. This one, the second one, this molecule, start numbering from the carbonyl carbon atom, 1, 2, 3, 4, 5, 6. So there is a methyl group on carbon number 5, so it will be 5-methyl hexanoic acid, because you remember this is the functional group of carboxylic acid, C double bond OOH. This molecule now start numbering from the carbon that's near to the carbonyl group, C double bond O. So I will start from here, 1, 2, 3, 4, and 5. So the name of this molecule is 3-methyl 2-pentanone. NONE. The last one is 5,6-dimethyl 3-propyl 2-heptanol.